Please pause the video and take a moment to read this important safety message.
Hey, welcome back everybody. Video here at Blue Glow Electronics today focused on finishing up this pair of C8s. Now if you remember, one of these was a master, one of these was a slave type unit, but there is very little difference in them from an electrical restoration standpoint. This one had a can cap turned this way and the other one had it turned this way. One you've got the gained volume and whatnot switches, but from a practical standpoint, we're going to clean these switches the same as I would clean this switch. They're, from a restoration standpoint here, just about the same. So what I'm going to do, you can see these old, dried, poor, rotted power cords. I'm just going to cut them off for the sake of not being in the way while we're doing the restoration here. And I've got some replacement units that I dug up that are in good shape. So let's dive in. I'm just going to show the restoration of one of these. The same would hold true for the other one. And then we'll get all these units hooked up and plugged up and playing together well here. Alright, what we're going to start with here is replacing the can cap. And just like with any restoration video I do here, I always start out with a little pad and I kind of draw out the end of that can cap and the tabs that are on it, and I kind of just mark everything off here and make sure that that I know where everything goes. The other thing I do is I always get out my handy dandy phone here and I take quite a few pictures of what's going on here, just so we know that in case we need to come back and reference something, we've got the pictures to go to. Okay, at this time we've got everything kind of drawn out here. I've gone through and snipped all the wires and this resistor loose, and I marked the top of this so I know how it came out, and then it's just a matter of sliding the old one out. And then at that point we can kind of come over here now that I can actually see, and I can mark the crescent here, the triangle here, and kind of the square symbol here. Let's see. Triangle, crescent, square, and then we can read off the side over here, and we know that the crescent is 20 microfarad at 450 volts. The square is 30 at 300 volts, and the triangle is 30 at 250 volts. So kind of got that laid out. I just like to document everything as I go. We're going to go get the new one and kind of slide it in here. Okay, at this time we've got everything kind of drawn out here. I've gone through and snipped all the wires and this resistor loose, and I marked the top of this so I know how it came out, and then it's just a matter of sliding the old one out. And then at that point we can kind of come over here now that I can actually see, and I can mark the crescent here, the triangle here, and kind of the square symbol here. Let's see. Triangle, crescent, square, and then we can read off the side over here, and we know that the crescent is 20 microfarad at 450 volts. The square is 30 at 300 volts, and the triangle is 30 at 250 volts. So kind of got that laid out. I just like to document everything as I go. We're going to go get the new one and kind of slide it in here. Okay, and as you can see, the new can cap is a little bit longer than the original. Could not find one this length without having a custom made from Hayseed Hamfest. But at any rate, it doesn't matter because we're going to turn these little bands so that the can cap goes this direction in the other unit versus that direction, and we'll have plenty of room then. This one was already turned in this direction. And if you'll notice on here, we've got 20 microfarad, 30, 30 at this 450, 300, 250, right? Well, this one, if you'll notice, is 30, 30, 30, 30. So we've got 4 sections here. We'll only end up using 3 of those. And they're all at 475, so they'll all exceed the specs here, so it really doesn't matter which one. This is our new friend here. His name is Mushu, and he was a rescue cat. He got ran over out in our front yard not too long ago. We found him in the yard, and both of his back legs were kind of messed up. We ended up leaving him at the vet for about a month, getting kind of taken care of and squared away, but now he is an indoor cat here living in my basement. And I got to get him out of the way. At any rate, so you can use any of these three in any direction, is my point here. So what I'm going to do next is cut these two. There's two 100k ohm resistors here between two legs, and I'm just going to cut these out of here, and I'll test them, and if they're still within spec, we'll solder them back on here. And if not, I'll go get some out of the bins. But we'll pick any three here, like I said, and kind of go between those two just the way it's done right here. And those tested out okay, and as you can see, I've got them soldered in here, going from here to here and here to here. And at this point, I'm going to go ahead and mount the unit in here, and I've got the top of the two where the 200k ohm resistors join together here on the very top. At that point, it's just going back to our little diagram. Remember, I had one marked here, red, coming from the board. I'm just going to get the red one coming from the board here, and I'm going to tack it on over here on this side, and we'll keep moving through it. Pay attention here, like on this one. I notice I'm coming from the red one here from the board, and I'm soldering it on here. The only other thing connected to that terminal was the 100k ohm resistor here. So I know nothing else goes here, so I can go ahead and solder that connection up really well. But like this one over here where I've got multiple things connecting to it, I always like to connect all of them before I solder the end up good. Otherwise you end up with a soldered up hole, and then you can't insert the next item into it. And moving on to the next one, you can see I'm here. I picked these up at Lowe's a while back. I really like them a lot. These are some Greenlees, model 1950A, but they're just little wire strippers already kind of serrated off. I've got others I use that don't have preset kind of connections on them, but one thing to pay attention to when you pull the wire off here, and you might be able to see it here if I zoom in a lot, sometimes these things will be green a little bit when you pull them off because they've got corrosion going on. If so, cut some of the wire off, try to get a little further up the chute if you can. If not, make sure you clean it really good. This one turned out to be okay, so I'll be able to solder it on. And it may be hard to see here, but I like to run my wires through the hole and wrap them around good the way they kind of were originally done, making somewhat of a physical connection before you make your electrical connection with the solder. Not a big fan of using solder to purely hold something in place. Alright, as you can see here, good solder joint, flowed all around, covered the area. Not too much solder, not too little, but that's not going anywhere. And if you'll notice, the length of this can being longer has created me a little challenge here with this resistor. Comes up here, and then it used to just push over and connect right on. Well, I need an extra, probably 3/4 of an inch there to be able to do that. And one way you could do that is to just use a piece of cut lead off of something else like this. Another, you could just take a piece of wire and run it over there and do that. A little hard for you to see, but I keep a bin just with wire in pieces like this. Got from various things over the years when I've had to cut wires for whatever reason. I saved this bin of just little wire end pieces, and it's perfect for using for something like this to make the jumper I need here. Okay, I'm going to be joining two pieces of wire together. What I'll do when I'm doing that, and I will always tin both pieces of wire really well before I go to kind of join them together perfectly. It'll help make this connection so much easier. And up next, I've got this little black wire that comes from, it's actually soldered in between these two sockets right here, in the connection between these sockets and to the chassis. And it feeds up, and it's actually the chassis ground here where this connects to for the capacitor lug here. But as you notice, it's too short. So instead of trying to jumper onto that, I'm going to replace that whole wire all the way back here. Okay, at this point we've got this all soldered up and back in place, and every wire connected to it. And we've kind of marked off our wires as we went here, so we are good to go with this part. Now, onto this selenium rectifier here. If you'll notice, it does have 3 connections here, so we're really going to have to replace this with 2 diodes, unlike in the MC30 where we were replacing that single selenium rectifier that was a single diode. This will be a two diode setup here. Okay, as you can see here, got the 3 connections. I've kind of drawn it out here on my piece of paper for you, and let me walk you through it here. So we've got a black connection here, a black connection here, and a black connection coming from here, all tying to this first blade here of the rectifier. Next we've got the yellow wire that goes to the center. That's the only wire that goes to the center. And then we have a black one, and we have a brown one that comes to this third blade here. And if you kind of draw that out in a diode equivalent, you'll have the 3 black wires coming to this first end, which is going to be the anode of your first diode, and you're going to kind of jump, create a 2 diode scenario here, and you're going to come off of your center section here with the yellow, and then you're going to come off the cathode of this end here with the brown and the black. So exact same scenario. Also, all we are rectifying here in this unit is the heater supply is really all this is for. These capacitors and this. All the rest of the power for this amplifier comes through the umbilical cord back here from the MC30s. So we don't have to worry a lot about, much like we did in the MC30. Remember in the MC30 we replaced that selenium rectifier? Well, it was used for the negative bias setting, so it was fairly sensitive to the voltage on the other side of it. Here we really don't have to worry about that. Instead of, I'll give you an example, instead of 6.3 volts on the heaters here, we may end up with 6.5 volts on the heaters. It's not a big deal. Everything will be just fine. So we don't have to worry about compensating in this scenario. Alright, before we can get this rectifier out, we do have to take off these little nuts right here, and I got to get a smaller wrench. Thought a 3/8 would be it. Be right back. Anyway, we've got to get these out, and there is a screw head on the outer part here of the unit, and it matches up with this. So once you can get it kind of broke free here, then you can just turn your screwdriver and get it the rest of the way out here. And as you can see, that drops right out, and then this will slide all the way out the back side. You've got the exact same scenario over here on this side. And as you can see now, this kind of comes loose, and then you've got another nut here that holds the selenium rectifier to this little plate. And you can see we've got the wires that would come off of this cathode here on this and would wire up to these electrolytics. And so we're going to kind of do all this at one time here. Okay, I've kind of drawn this out for you now, the way C1 and C2, and I've titled this top one here C1 and the bottom one C2. But C1 just comes off the yellow wire here and comes over the positive side of it. It is an electrolytic. The other side of it goes to a socket, which is a pin on this socket way back here off the negative side of it. C2 comes off of this point here where the 2 black wires are for the positive side, and the negative side comes all the way around over here and ties in, and it's one of these black wires that comes in over here on this side. So all we've really got to do now is remove all this and kind of wire it up this way. So once we kind of remove the plate, what I did was I cut these tabs off to kind of keep things intact for a minute. You can see I've got 3 solder points here, right? There's the one point that had the 3 black wires coming together. Then we had the point that had the brown and the black coming together. And then we had the point with the yellow on it, which is right here, but there's really nothing on the other end because I snipped out the two capacitors. Check out these. 2,000 microfarads at 15 working volts each. These things are monsters. I'll show you what we're going to replace them with. So as you can see here, significantly smaller these days. These are 2200 at 50 volts, Nicky Cons, and really good capacitors here that we're going to use on this. But as you can see, we won't use up near the space. Okay, because I hate, leaving something not somewhat authentic. If you'll notice, I put the two screws back in here, and on this side I kind of mounted the plate against the wall here just so that all the original components are still with this unit from a kind of chassis standpoint. This won't be used at this point, but at least it's here and not being thrown away. Okay, as you can see here, I used just a little bit of glue to hold these down onto the board. There's a nice spot here unused, and kind of put them in order here, negative, positive here. But now we've got a nice place to tie off to and to solder all the components. Okay, up next you'll notice this brown wire that's supposed to connect onto one end here is a little short for what we need, and I don't want to pull it too tight. So what I'm going to do is flip the unit over here to where the brown wire originally connects right here on this tube socket, and I'm going to just run a new wire instead. And as you can see here, a new wire soldered on this side. Alright, similarly C1 negative where it goes to the socket, that wire is too short, so I've now flipped the unit over here onto the socket, and where that wire connected right down here, I've now snipped it off, and I'm going to run a new wire up. Okay, as you can see now, I've connected a new wire here, and I'm going to run it down through and tuck it in and run it to the new place. Now, I'll say this, take it with a grain of salt. I'm not saying I'm better than any other tech out there, because there are a lot of good techs out there, but I have seen a lot of work come into my shop over the years where people just, they wouldn't have taken the time to unsolder this from the original socket here and run a completely new wire. Instead, what they would have done was taken this wire that came up through here, and they would have tacked another wire onto the end of it, and they would have ran it over here and soldered it off. And would it work electrically? Yes. Does it leave an ugly, messy job? Yes. But I see a lot of it. So just saying that for what it's worth. Is this time consuming what I'm doing? Yes. But ultimately, at the end of the day, I think that's a kind of a differentiator in some of the work I do versus some of the work I have seen. I won't say versus other techs, because there are other techs that do really good work out there. So I'm just saying versus some of what I've seen elsewhere in the past. So maybe all those people have passed on and aren't doing work anymore, but I continue to see stuff brought into the shop from time to time that's, I'll use the word butchered up as the best way I know to describe it. Similarly, I'm finding yet another wire not quite long enough, and so I'm going to go flip it over to where it connects at right here and replace it with another little piece of black wire here. As you can see here, got our new wire soldered on. Alright, let's dissect a little bit of what we did here, okay? So if you'll notice, the two black wires, they come together, and I labeled this capacitor closest to the back of the unit here as C2. If you'll notice, those two come together along here with the anode of this capacitor here tied together in 3 points. And so if you'll notice here, the negative of C2 and these other two black wires all tie together here on the anode of this capacitor. That's done. If you'll notice the middle section here, we've got this brown wire that comes in, okay, which is this one here. The black wire itself was actually the capacitor, and that is the positive of C2. So if you'll notice, the positive side of C2 here has the brown wire, but if you'll notice, the positive side of C2 right here also has the cathode side of this diode, which is right here. If you'll notice, the anode side of this diode, it ties over here to the positive side of C1, okay? So if we see the positive side of C1, we notice the other side of this capacitor, we're tied off here, and then we've got the yellow wire. Well, the yellow wire was really this wire leading here to the positive of C1. The other side of that C1, the negative, is what goes down to the chassis. So the negative side of C1, that's the new wire we ran right here going down to the chassis. And so that kind of completes it. We've got everything lined up nice and neat. I ran these diodes. If you notice, there's a little bit of separation here. I'll raise that up so nothing is touching there. It all looks nice and neat, much cleaner than what we had before, and that will now power the filaments in this unit here. So at this point, we've got the kind of the electrolytic and rectifications part done. We've also got this large electrolytic in place here and all wired up. So really what's left on this unit now are replacing all these capacitors on this board, and my goal is to make it through these today. So it is Corona time here. We are isolated and hunkered down in our basement and trying to go out as little as possible, and so it's a good time to get to focus on some of this here. Let's dive on into replacing these. You may wonder why I take all these notes on little things here, but as you can see, I just tape them into my book when I'm done, so I don't. So if I ever run across another pair of C8s, I would have these in here, and I'll end up just taping this in here. But getting back out our books so we'll know what caps are what, make it easy here to kind of identify as we go through this. Failed to mention the diodes I use. They're just 1N4007s. You know, these things are pennies a piece and readily available, so nothing special here. Okay, I'm going to go through now and start replacing, just work my way, you know, one end to the other. Here we got a 0.01 microfarad. There's another 0.01. Let's see, that's a 0.01. And we got another one down here, way down here at the other end. And I'm going to be using these Zoso capacitors here, the 0.01 at 400 or 500 volts. I'm sorry, to replace these with. The original, those what were in here were 400 volt capacitors. There again, if you're not making a video, I would recommend getting out your handy dandy camera and taking pictures of everything and every wire lead along the way. It is super easy to get off. I'll give an example. This one here goes to here into this hole, but then this one goes to this hole and this hole. So it would be really easy to wire this one back in potentially to the next hole, and you can see here this next one goes to this hole and this hole. It'd be really easy to come off of this one here maybe and go right down to this hole, because that would be straight below it. So it just helps to have a backup in case something doesn't work out. You can always go back and reference for where you started at. Typical McIntosh style, they would come through these holes and then they would wrap the capacitor leads around before soldering, which makes it really a pain to get these back out. You just have to take your time and go slow and work with them. And if you'll notice, I got one out. I was dealing both not only with physical connection, I cut them both loose on the other side, but also this through hole here, this via, had solder coming all the way through it. So I use a solder sucker. I like to use this little engineer solder sucker is what it's SS020, and I don't know where I got it at, but I've had it a while. But I will try to suck the solder out of this hole so that I'm not dealing with it as I'm trying to push the new one back through. And much like the original, you can kind of see I came out and wrapped around here. Similarly, I came out on this one here and I'm wrapping around here. Just trying to preserve the original kind of design and mounting of how they did these capacitors. One for aesthetics, but two so it's good and solid. And as you can see, there's one down. That was, I timed it. It was 6 minutes and 49 seconds worth of work to put that capacitor in properly. So you do the math on that. What we got, about 20 of them here times 620. So you're at least 2 hours, and that's with no breaks, and that's just click, 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 click. So if somebody tells you that they can do a job like this in 30 minutes or so, you probably don't want them working on your app. Okay, I'm trying to show you what I'm doing here. Where the original wires, like in this case, there's two capacitors that tie off to this lug. And what I'm doing here is where they come through and then do the wraparound, I'm cutting them so that then, and sometimes you have to cut through the solder, but then on the other side, what you can do is you can simply, oh, I've got solder holding them in place as well. Let me show you here. Let me heat the solder up a little bit here. But hopefully after you've snipped them on the other side, see, the units pull out completely. Similarly here, the other side of this one here pulled right on out, you can see. That leaves the hole wide open, and you can kind of go back through there now with your new items. Sometimes you have to pay attention. You not only do you have capacitors going through the through holes, but you also have wires, and just be careful as you're snipping and whatnot that you don't lose connectivity to those wires coming through the other side. Alright, just sitting around here kind of flattening out wires using a pair of flat nose pliers, getting leads straightened out. Working our way through, about halfway through now at this point on this unit, but I was having an interesting conversation with another technician at the Shelby Hamfest last year, and the conversation went around something like, why do you think you see so much kind of just, makeshift work, or looks like it's really been done really fast and whatnot? And the interesting part was, the technician said, well, do you think you could do it the way you do it? Take your time, do all these things right, and still make money off of it. And I said, absolutely not. There's no money to be made in this. If somebody thinks they can quit their day job and restore vintage gear and make a living off of it and do it aesthetically correct, about the only way you can do it is charge a fortune. And maybe there are people willing to pay a fortune, but it's kind of like restoring an old car. It's the difference between taking it to Mako and getting a $300 paint job on it, where they would basically tape up all the windows and all the chrome and trim pieces and spray paint your vehicle, versus taking it to somebody that's going to do a frame-off restoration on your vehicle that might cost $60,000 or $80,000. And I'm in the mode of doing the frame-off restorations to some degree, and others might be into the Mako paint job. So there's a difference between restoration and aesthetics and trying to get it back the way it was and all that, and kind of, I won't call it sloppy work, but quick work, just to get something functional again. And I struggle with that, so I won't be quitting my day job anytime soon. And when I do, I'll be retired, and then I can do this and not worry about it being a money maker, more of a hobby at that point. So at any rate, a little food for thought today. Okay, up next is this 50 microfarad here at 6 working volts. You would be fine using a 47 microfarad here at 10, 20, 30, 40, 50 volts, whatever. I just happen to have some 50 volt at 50 microfarad at 50 volt capacitors, so I'm going to use them, but like I said, you'd be fine with a 47 here. I am seeing one difference between the C8 and the C8S here. Right here, same capacitor value, they just used a red striped, which is the 400 volt version, and a 200 volt version here. And if you'll notice over here on the equivalent on the other side, they use 2 red versions. So interesting. I imagine you can get by with either one, but I just thought I'd call that out. We're going to use some Selenium 0.47 at 630 volts for all 4 of them, so it really doesn't matter. Okay, I'm down here working on these right now, and these last 4 or 5, 1, 2, 3, 4, 5, Might take as long as all the others. They're a pain, this being in the way, and I just don't want to remove that. It would be an equal amount of work. So slow and steady as she goes. Alright, I gave up a little bit. What I did was I pulled this knob off the front here, used a nice chrome smooth wrench on it here, and took this nut off the front here on the unit. And what I'm doing here is I'm just giving myself enough wiggle room with this unit to be able to turn it a little bit so that I can actually get my fingers around it on the other side and reach down in here and pull components up and out. If I didn't, this would never happen. Okay, we've got the whole unit done on this side. I will tell you, these last 5 right here took as much time as all of these, just about. Royal pain to deal with working down in this tight area down here. All right, I thought I'd pause the video right here on part 2. The reason being, part 2 turned out to be a little over an hour in length, and I think that's too much to maintain anyone's attention at any one point in time. So I'm going to break this up into part 2 and part 3 and pick the video back up in part 3 soon. So we'll call this end of part 2. And part 3 is really good because not only do I finish the units, but I show you how to hook all of these units up and the interconnectivity between the C8 and the C8S. And then we actually demo these units. So stay tuned for that. Thanks for watching.